It is a historical discovery worth its weight in gold. A truly important document of German aviation history is uncovered. It is not found in the archives or by any secret military personnel after the war. It happens instead by accident. On an ordinary day for this factory worker, he discovers a sealed canister containing a drawing. It appears to be a blueprint for the design of an aircraft. On closer inspection, the document dates back to the mid-1920s. What it turns out to be are the workings of a deadly state-of-the-art bomber, illegal in Germany at that time. Its origins are inspired by this strangely designed plane. It may look backwards, but the logic behind the design is truly forward in thinking. It is one of the original tail-first Canard-designed planes, and the concept behind it demonstrates Germany's desire to be at aviation's vanguard.
In the Ente, again the duck, late 20s, they had this design. Tail first, not really an airliner, but a few seats. The tail first design would allow you to triumph against the stall. The stall was very much a feared thing. You lose control, you crash. A Canard, a tail first design, can say that if forward tail stalls, nose goes down, pick up speed, airplane stays in the air, all is well. The prototype flew around 1927-28, worked quite well.
It is an unconventional design by an unconventional designer. Heinrich Focke is hoping to remove one of the pilot's biggest concerns since the birth of aviation, the dreaded stall factor. Thus, the design is catching the attention of aviation enthusiasts from around the world. Innovative as the F-19 may be, it is not without its flaws.
Eventually, it crashed. If you lose control of it at low level, it's deadly. And Mr. Wulf, the Wulf of the Focke-Wulf, he's the one who died in the crash.
With the death of their founder, and with military aircraft strictly forbidden in Germany, those at Focke-Wulf are now at a fork in the road. Do they keep on developing Canard technology for peaceful and, most importantly, legal purposes? Or do they risk both the company's future and their freedom by turning it into a deadly weapon of force? In an extremely risky decision in the history of the company, the plan for the F-19 dramatically changes. Instead of being the originally planned sports plane, it is now going to be a deadly bomber, capable of causing tremendous havoc over Europe's skies. The man behind this madness is one of Germany's true engineering geniuses, Kurt Tank, who joins Focke-Wulf as a result of a company takeover. Being there every step of the way, he harnesses and perfects this technology into what becomes known as the Model 42. The source of funding for this ambitious project in an economically starved country is still unknown. However, there is one thing for certain. Germany's quest to rule the skies is something neither military defeat nor monetary limitation can stop.
Tail-first design was developed for a number of reasons. If you have a Canard configuration, you have a very thin nose because your engine is behind the pilot. You can technically, at least in theory, increase speed with the same amount of power, which is good for combat aircraft. Also, because you have a fairly thin nose, you can improve, to a certain extent, pilot visibility.
When completed, this aircraft, powered by BMW's V12 engines and possessing a maximum speed of 200 miles an hour, is for Germany both her sword and shield. Any potential enemy will think twice about pushing around a Germany possessing an arsenal of aircraft carrying 20 200-pound bombs on board. More importantly, if Germany desires to reclaim her lost territories following the Treaty of Versailles, the Model 42 can put immense fear into both Europe's citizens and industries with its capability of causing enormous destruction. As testing rapidly advances, ironically, the rug is pulled from underneath them by neither pacifists nor neighboring European powers, but by the most militaristic regime in history. As Hitler's Nazi Party comes to power in 1933, the newly installed Chancellor's main interests are in maintaining and consolidating his power. An illegal aircraft project, if discovered, could be the end to his fragile rule. As a result, the project dies alongside German democracy. Although the Model 42's future is ended with the single stroke of a pen, the concept of Canard technology lives on. Focke-Wulf obeys the government's decision, but at the same time rapidly develops what is known as short takeoff and landing technology. One of its crown jewels is the FW-61, the world's first fully controllable helicopter. Its creator, Professor Heinrich Focke's, much like his German predecessors, symbolizes that an idea can never be defeated, no matter what obstacles it may face. Had this bomber plane been approved for production on a massive scale, one can only imagine what impact it would have had on the Second World War. It is one of the conflict's greatest what-ifs. In fighting both Britain and the Soviet Union, it might well have tipped the scale in favor of Germany. The Model 42 thus may have resulted in a soaring victory and changed dramatically the outcome of the war in Europe.
I name you hero and wish you good luck and Godspeed to all who fly in this type. Yeah? Thank you very much.
Despite the enthusiasm at Handley Page, the mood in England at this time is anything but cheerful. By 1937, the drums of war are beginning to be heard across the nation. Never has this been more evident than at these factories, where the Harrow is being introduced in an attempt to showcase Britain's military power. Unfortunately, it is technologically years behind the now cancelled Model 42. With $400 million being spent on aviation in a single year, the government assures its citizens that they have nothing to fear with this powerful weapon on their side. However, the question remains as to whether these bombers can stand up to the growing German threat. These fears are finally realized as Britain's cities are repeatedly bombed by the Luftwaffe, causing enormous destruction and loss of life. The Blitz has now focused the world's attention to what the bomber is capable of doing. The nation everyone is looking to is in dire need of a solution to this deadly problem. It may be one of Britain's most unusual designs for a plane. At Miles Aircraft, this prototype, known as the Libellula, marks not only the resurrection of the Canard design, but also exemplifies a company truly thinking outside the box.
People were very appreciative of the fact that Miles had this wonderful innovatory streak in them, and that they might come up trumps with something.
During the war in Reading, Berkshire, the factories of Miles Aircraft are working overtime, making a substantial contribution to the nation's war effort. What is capturing the imagination of the company's top designers is the reconstruction of a revolutionary aircraft. A plane that will capture massive attention with a design so futuristic that it is years ahead of its time. Hard at work with their initial sketches by ambitious and intelligent designers, the Canard plane is reborn. In this factory, British men and women are side by side, hard at work putting together this complicated design. While their soldiers are fighting on the front lines, these workers have stayed behind. Their job is to maintain the production of wartime equipment on the home front. And a mighty task for them is to construct this unusual plane possessing a tandem wing arrangement, requiring countless hours of labor. Unlike standard aircraft, the Libellula M35 has its wings at different heights and at different lengths. The reason for this is that the lesser wing acts as a forward-mounted stabilizer, thus improving control, especially in regards to landing. With its shorter wingspan and not requiring them to fold, when completed, the M35 is to be used as a carrier-borne naval fighter. Its sister plane, the second of the Libellulas, with an additional engine, is intended strictly for bombing purposes. Its creator, George Miles, says that when completed, the plane will resemble a dragonfly. In just 90 days, the first plane is built, remarkable for its time. Those at Miles Aircraft are determined to see what this plane can do once it is up in the air. Getting the plane ready for flight, engineers are putting the Libellula in position. As the final inspections are being conducted both underneath the plane and in the cockpit, the company, having a huge investment in the aircraft's success, hopes to put it into mass production shortly, pending government approval. Possessing a tricycle landing gear, the intent is to achieve complete stability when landing. At the rear of the wings are the corresponding vertical and horizontal stabilizers and rudders. Once in the air, the plane is able to fly at 160 miles an hour and climb at a rate of 1,100 feet a minute. Its Canard features lend the aircraft well to both high and low-speed flight. With all of its advantages, however, the Libellula is not without its drawbacks.
So the Libellula, the problem was to control the aircraft for takeoff and landing. It had 2 sets of flaps with 5 settings for each set. So you had a potential 10 combinations. This was difficult because getting the right combination was one thing, because every time you changed the combination, it had some effect on the controllability of the aircraft. And it was really impractical.
Complexity becomes its Achilles heel. And despite the optimism from those involved in both the flying and the making of the plane, the military situation at the time dictates that the Libellula must come in for a political landing. In many ways, it is surprising that both versions of the design never go into mass production. However, its fate, similar to that of the Model 42, rests not on the aspiration of its designers, but on external circumstances. Britain, now with the United States and the Soviet Union as allies, is turning the tide against the German war machine. As a result, the demand for the Libellula evaporates. With prospects for the Canard design now looking all but dead, miraculously, it once again is resurrected. This time, however, it is not done by any European power. Instead, it is done across the Atlantic Ocean, in America, the birthplace of aviation. Here, the Canard design is reincarnated. The United States, referred to by Japanese Admiral Yamamoto as the sleeping giant, has awakened. Having an industrial capacity second to none, geography is the country's greatest asset. A massive labor force working uninterrupted, without fear of factories being bombed, is Uncle Sam's greatest advantage. And aircraft production is no exception. In terms of quantity, the United States is the undisputed champion. No European nation can even come close to their rate of production. However, while the country leads in quantity, it is quality that one aircraft company aspires to excel at.
But there was definitely a potential there. So Lockheed started to look at what kind of airplane could be designed around a turbine engine for high-performance aircraft.
It is Lockheed who believes it has the jet-powered solution for the fighter. One of its most secret projects of the war is the L-133 prototype, which is tested to see if this new technology can be harnessed into something tangible for the United States military. Thus, the Canard design, an important component of the project, rises from the ashes. At first, the Army Air Force show interest in the project. The emerging military-industrial complex, however, dictates the final decision, with it becoming a case of quality versus quantity that ultimately determines the project's future.
They looked at it and sort of, well, this is all very interesting, but you have an engine that's a wee bit on the complicated side, and you're producing Hudsons for the Brits, Lightnings for us, you're producing light transport aircraft, and in some cases, like Lightning, for example, your deliveries are good, but may not be quite as good as we would like them to be. And you want to get involved in the design of a new type of engine and a new type of aircraft. Please slow down. Our enthusiasm is not necessarily there.
With war raging on in both Europe and the Pacific, a policy of producing what is known and reliable is enacted. Every second must be accounted for. With the possibility of the model not functioning properly, precious time must not be spent testing the unknown. Thus, the L-133 becomes, much like the Model 42 and the Libellula, an aircraft whose potential remained unfulfilled. There is no doubting, however, with its state-of-the-art technology, the development of the L-133 would have brought Canard technology to a new level. It is the right place, just not the right time for Lockheed. To the employees at Curtiss-Wright and Canard enthusiasts, deliverance has arrived with the XP-55, known as the Ascender. With the main wings located at the tail end of the fuselage, it is certain to attract attention due to its unique design.
Presenting the Army's new Ascender plane. With its elevator controls in the nose and its motor and propeller in the rear, this push-propelled fighter reverses conventional airplane design. Developed experimentally as the XP-55, the new plane gives forward vision for the pilot and a clear path for his gunfire. In action, the darting tail-first Ascender seems to fly backwards.
Its origins lie in an Army Air Corps flirtation with unconventional aircraft design. And nothing defines the unconventional like the tail-first plane. Despite a policy of turning out proven aircraft on a massive scale, there is some room for experimenting. Originally intended as a design to be powered by Pratt & Whitney liquid-cooled H engines, it is perhaps the best chance Canard technology has of becoming more than just a blueprint or a workable prototype. Mass-scale production is the ultimate goal of its enthusiasts. After extensive testing, it appears that the Ascender is the best hope in achieving this goal. The Air Corps is impressed so far and asks for 3 prototypes to be built. The plane's future, however, comes crashing down with its first prototype. A stalling malfunction results in the first Ascender taking a 16,000-foot nosedive. As the company attempts to fix this problem, competing technology is evolving faster than XP-55. In the end, the project is cancelled indefinitely. It is not worth either the government's time or money to further pursue such a risky endeavor. Despite its name, in the end, the plane does nothing but descend into the depths of aviation history. By 1945, as Japan enters the 4th year in its war against the United States, the sleeping giant that Admiral Yamamoto feared would awake is now on his nation's doorstep. After massive casualties on both sides, American military power is successful in pushing back Japanese forces through both its superior air and sea power. The American mainland remains untouched after Pearl Harbor, with military production skyrocketing. Japan, a nation that seemed invincible in early 1942, is now feeling this incredible American force wreak havoc over its mainland. In particular, Japanese cities and their inhabitants feel the horrors of an air war that does not distinguish between military and civilian targets. American B-29s, leaving from the islands of Guam and Saipan, fly a total of 107 bombing raid missions on Japan's cities in just 1 year. One particular raid that takes place on the night of March the 9th destroys 250,000 homes and burns almost 100,000 citizens to death. In General MacArthur's historical report, he writes that the effect of these raids rocked the nation to its very foundations. With each passing month, the casualties keep escalating, with nearly 3 million people killed. Mass famine is spreading, with an estimated 10 million people suffering from serious malnutrition. Japanese Admiral Matomi Ogaki, writing in his diary on June the 18th, asks, "Does the enemy intend to destroy all of the cities in this country?" General Curtis LeMay, a key architect of this bombing strategy, pledges to bomb and burn them until they quit. The only problem for LeMay is that with a schedule of approximately 16 burn jobs on urban industrial areas every 3 to 4 days, by mid-August, American bombers will run out of cities to destroy. Japanese air forces are proving incapable of preventing this mass destruction of their homeland. A carrier raid in March of 1945 results in 161 out of 193 Japanese aircraft being shot down by American forces. Vice Admiral John S. McCain pledges to hunt down and destroy every damn plane in Japan. Despite the much-feared kamikaze tactics being employed by Japanese pilots, American military leaders are no longer planning the possibility, but the eventuality, of Japan's surrender. The maps being used by both the Joint Chiefs of Staff and the President show that whether it is through a ground force invasion or through the dropping of an atomic bomb, Japan is a nation on the brink of defeat. The only decision being made by the political and military leaders of the United States is which course of action they should embark on in order to achieve the goal of an unconditional surrender. To those Japanese military leaders who are in their last throes, their hope is to develop a highly maneuverable interceptor plane to act as an antidote against American B-29s. The Shinden aircraft, developed by Kyūshū, is the only aircraft with a Canard design to be ordered into quantity production during the Second World War. Equipped to hold one pilot and having a wingspan of 36 feet, armed with 4 30mm cannons and a top speed of 466 miles per hour, in addition to its important Canard features, the Japanese military is hoping the Shinden holds the answer to solving the problem of the B-29 bomber. Work begins in June of 1944 to develop this plane, whose name translates to Magnificent Lightning. By now, however, time is not something Japan has on its side. Although the first prototype of the Shinden flies on August the 3rd, it is simply too late to prevent a devastating American attack. 3 days after it is tested, the first atomic bomb is dropped on Hiroshima. 3 days later, the city of Nagasaki is dealt the same blow. With these two bombings, in addition to the Soviet Union declaring war against Japan, the demand of unconditional surrender is met on September the 2nd, 1945, marking the end to war in the Pacific. The story of the Shinden remains one of the greatest what-ifs in Second World War history. Had Japanese production and testing begun earlier, would this aircraft have been able to stop American bombing plans as hoped? If the jet technology for this aircraft arrived in time, would the Shinden have been to Japan what the Spitfire and Hurricane had been to Britain in its time of need? For it remains an unknown piece of Canard history. The Canard design, with its origins dating back to the Wright brothers and their first flight of 1903, is a story of aviation constantly having to overcome the barriers and obstacles put in its way. It is a story of emerging and innovative technology locking horns with the politics of its time. Whether it is a result of a new government taking power, the policies of production, or of a country in desperation, Canard technology never soars above these barricades in the first half of the 20th century. There is no doubting, however, what Canard technology represents in the history of aviation. It symbolizes the innovative spirit, and it symbolizes the proud heritage of aviation. The Canard design is to be remembered through its planes and by the people that created them.
In about the late 1940s, or maybe 1950, the Air Force conducted a competition for a long-range jet-propelled escort fighter. The competition consisted of the XF-88, built by McDonnell, the XF-90, built by Lockheed, and the XF-93, built by North American. All three, and they built 2 prototypes of each airplane and ran them at competition. All 3 airplanes flew quite well, with one minor exception. They didn't have much range, which didn't make them much use for what they were wanted. So the program was canceled. However, people wanted to do something with the prototypes that were left over, and the propeller lab at Wright-Patterson, trying to preserve itself in the jet age, came up with the idea of converting the number 2 XF-88 to be propelled by a turboprop engine with a propeller. The purpose being to develop a supersonic propeller capability. Now, bear in mind, it still had its regular power plant of 2 J-34s with afterburners. McDonnell built the airplane. They put an Allison XT-38 turboprop engine in the front part of the airplane, which took up an awful lot of space, and put a propeller on it. The original propeller was one that the propeller lab felt was reasonably safe to go to high speed. It was a 10-foot diameter. It was a very, very interesting program. Because of the diameter of the propeller, if the nose gear contracted completely, the propeller would hit the ground. So, and also it was not designed with an offset vertical fin like all propeller-driven airplanes are to counteract torque on takeoff. So what we did was we always took off with the propeller in the feathered position in an X, so the blades were as far from the ground as possible, which in turn caused all sorts of comment. And since I was doing this at Lambert Field, which is a commercial field in St. Louis, from airplanes waiting to take off, you know, there would always something to the tower, the effect of, I presume that pilot knows what he's getting ready to do with his engine feathered, but yes, we did. The other thing I should mention was that if you thought that the airplanes were short on fuel to begin with, after they put that XT-38 in, they took out so much fuel that this airplane had 288 gallons of fuel. Now that was to run 2 J-34s with afterburners plus the turboprop. So the flights lasted between 15 and 20 minutes. Take off, climb to whatever test altitude it was, make one acceleration, throttle back, feather the prop, come in and land. During the latter part of the program at high altitude, when I'd finished the test run at whatever speed I could get the airplane up to, and the propeller worked reasonably well. You could notice the increase in power above 0.9 Mach number. The airplane would go about 0.91 with its afterburners. And then if you added power, you get up to about 0.94. The airplane, however, when I started to dive it, would get up to about 9.5, and then that would be about it. Well, McDonnell was claiming that I was getting supersonic in these dives based on their airspeed calibration. Well, we didn't quite buy that, in that we had a rule at flight test that no jump, no supersonic. So on the very last flight scheduled out there, I told our people to stand out on the ramp, and I would end up aiming the dive at the field. And if they heard a sonic boom, we'd say, okay, you went supersonic, regardless of what the airspeed indicator said. Well, it turned out that I ended up overflying the field ever so slightly. So instead of just pushing over into a dive, I rolled over and split S. And wow, things started happening real fast. I got the jump, plenty. I got a firelight on the turboprop and both jet engines. But eventually everything slowed down, the lights all went out, and came in and landed. The tower had long since informed me that, yes, I had been supersonic. Several years later, when I was managing the General Dynamics office in Houston, old Mr. McDonnell was there down at the Cape for a Mercury shot. And I was introduced to him, and somebody said, you know, and he's the one that flew the XF-88B. And he said no, and except he got about 3 feet away when all of a sudden it stopped, and he turned around and said, I remember you. You're the one that caused us 3,000 claims against us for broken windows. oh, Mr. Mack never lost sight of the important things.
The German Messerschmitt Me-262. Sleek, fast, and heavily armed, it was a quantum leap in fighter technology. For the Allies, the appearance of the new swept-wing fighter caused a great deal of anxiety and consternation. Nothing they had could come close to its awesome performance.
The top Allied fighter at the end of the war was the Spitfire Mark 14. With a top speed of 446 miles an hour. The Messerschmitt 262, which we captured and tested at Farnborough, had a top speed of 568 miles an hour. An advantage of almost 125 miles an hour, which means an aircraft with this performance, which is a quantum jump, can dictate terms of combat. It can initiate or finish combat as it wishes. It was a very formidable weapon indeed.
Considered by many to be the world's first jet fighter, it was in fact a distant second. Indeed, the first air-to-air kill credited to a jet fighter goes to the Gloucester Meteors of 616 Squadron RAF. On August 4, 1944, Flying Officer Dixie Dean, using the wingtip of his Meteor, toppled a V-1 flying bomb, sending it crashing into the ground. While the V-1 was a pilotless aircraft, it would still go down in history as the first jet versus jet encounter. It was a telling indictment. After a 21-month lead in jet fighter development, the Germans found themselves with just one design in production, the Me-262. By June 1944, only a handful were in service. But there was another jet fighter, one designed and built before the Me-262, the Heinkel HE-280. Designed by Ernst Heinkel, it was capable of over 500 miles per hour. At this late stage of the war, the HE-280 was nowhere to be seen. First flown in September of 1940, it was 2 years ahead of Willy Messerschmitt's Me-262. What happened? Was it simply indifference on the Luftwaffe's part, or was the promise of the HE-280 sabotaged by political interference, incompetence, or bitter personal rivalries? To find the answers, we must first look at the state of military aircraft design and production, beginning in the 1930s. Since the end of the First World War, aircraft engine horsepower steadily increased. At the beginning of the 1930s, new engine designs and the promise of the supercharger led to more and more horsepower. It was also the time when fabric gave way to steel. The new all-metal monocoque airplane revolutionized aircraft design. The possibilities seemed limitless. Speed, altitude, and range records were smashed. Military commanders saw great promise in these new designs, and as Europe crept toward war, orders for new bombers and fighters began to rise. With little time or money left for the development of any new or questionable propulsion systems, work focused on the evolution of the piston engine. Many engine builders called the idea of a jet engine the thing, technically unfathomable and little more than a pipe dream. But there were those whose pipe dreams would become reality. In 1930, Flying Officer Frank Whittle, RAF, applied for a patent for his jet engine. This was followed by Hans Joachim Pabst von Ohain and his secret jet engine patent in 1935. Robert Pohl, a colleague of Ohain at the University of Göttingen, was instrumental in bringing Ohain's invention to the attention of leading German aircraft manufacturer Ernst Heinkel.
This man, Pohl was his name, he wrote to Heinkel, whom he knew. And he said, I have a man here who is into something which I think has a tremendous future to it. He is into jet propulsion. It's a continuous combustion engine. It draws air in the intake, compresses it, and then the combustion cans are sprayed with gasoline, and it turns a turbine wheel to keep the thing running, and the exhaust comes out the aft end of it. As long as you give it fuel, it'll run forever. And he says, I have a man here who wrote a thesis about this sort of application for a jet engine. It pleased me very much if you would meet him and see him and talk to him about his ideas and his applications for future aircraft.
With Heinkel's backing, the German inventor created a line of experimental centrifugal flow jet engines, similar to Whittle's, each with ever more thrust. The entire program was conducted as a private venture and in the utmost secrecy. The German Air Ministry was kept in the dark. On the other hand, Heinkel was also unaware that BMW was working on their own jet engine. BMW's design was an axial flow unit. More complicated than the centrifugal design, it offered more power and greater efficiencies. It was also being developed with the full knowledge of the German Air Ministry. In time, axial flow designs would power Germany's fledgling jet force.
Early in the days before, immediately before the war, the Germans had become aware of the practicality of a jet-propelled engine as being pioneered by Frank Whittle. And at first, they followed the same concept as Whittle of centrifugal flow, which is the simplest form of jet engine, really, and also probably the most reliable at that stage, certainly, in the pioneering efforts. But eventually, they turned quite rapidly after their first, if you like, experiments onto the axial flow type, which really offers many advantages. And they concentrated thereafter totally on axial flow engines. And within the limitations of the strategic materials they had, they were very successful in this. The only problem was that the axial flow engine is complex and therefore difficult to produce, time-consuming to produce. And also, unless you have the right strategic materials to contain the heat stresses, it can have a rather short productive life.
Work on a suitable test airframe for Heinkel's revolutionary new power plant was conducted at the same time. By August 1939, both engine and airframe were ready. Heinkel's HE-178 was no masterpiece. The short fuselage and stubby, elliptical wooden wings did not exude a sense of speed. On August 27th, test pilot Erich Varsitz settled himself into the cramped cockpit of the tiny aircraft. Watched by Ernst Heinkel and a small group of mechanics, the HE-178 began to roll. The takeoff run was short. Climbing to 500 meters, Varsitz circled the airfield once and came in for a perfect landing. Total flight time, 7 minutes. History had been made. Wasting no time, Heinkel telephoned Ernst Udet, the chief of aircraft procurement and supply at the RLM, the Reich's Air Ministry. The response Heinkel received was far from enthusiastic. The world's first jet would have to wait. On September 1st, Germany plunges Europe into war. Long before 1939, the name Heinkel had become a household name in Germany. Indeed, Ernst Heinkel's Flugzeugwerk had gained a worldwide reputation despite considerable restrictions placed on German aviation by the Versailles Treaty of 1919. During the 1920s and 30s, Heinkel produced a number of new military types for countries like Sweden and Japan. With the rise of Hitler in 1933 and the expansion of the new Luftwaffe, the opportunities for Heinkel seemed endless. Orders for fighters and bombers began to pour in. While many of Heinkel's designs, like the HE-111 bomber, were very good, they lacked what he desired the most: speed. Heinkel was passionate about high-speed flight.
Well, Heinkel, he loved aircraft that flew fast. He wasn't all that into aircraft that were fighters, propeller-driven fighters and escorts and that sort of stuff, like the Focke-Wulf 190 or the Messerschmitt Bf 109. He was a man consumed by speed. The faster an aircraft knew, man, I'm for that.
Even before the first flight of the HE-178, he created the HE-176, the world's first rocket plane, in 1939. Unfortunately for Heinkel, official reaction was muted, and with the onset of war, all work on the project ceased.
Udet, Göring, and all those other people in the early Reichsluftfahrtministerium were propeller people. They believed airplanes that were driven by propellers and alternate engine systems. They said, no, an airplane flies best with propellers. And so Heinkel was looked upon as some kind of a crackpot. And the research he was doing on jet engines, they felt was just silly and waste of money. And so he never got any real support from the Nazi government.
Shortly after Hitler came to power, a new requirement for an ultra-modern single-seat monoplane fighter was issued. Heinkel's response was the HE-112, powered by a 695 horsepower Rolls-Royce Kestrel engine. Its direct competition was the Messerschmitt Bf 109 V1, also powered by the same Kestrel engine. The results were very close. While the Bf 109 was slightly faster, the HE 112 had a tighter turning circle and superior field performance. Amid general surprise and many raised eyebrows, Messerschmitt was awarded the new contract.
The Heinkel 112 was the better airplane as a combat airplane, and Rechlin test pilots endorsed that view entirely. So there was no doubt that from the pilot's point of view, Heinkel's 112 was number one.
For Heinkel, it was a bitter disappointment. It also marked the beginning of a new and rocky relationship between the aircraft manufacturer and the German Air Ministry. Undeterred, Heinkel continued with his quest for speed. Despite the lack of enthusiasm from Ernst Udet and later Erhard Milch, the State Secretary, Reich Air Ministry, Heinkel pressed on with his privately funded HE-280 twin-jet fighter. At the same time, the Messerschmitt Design Bureau completed a new twin-jet design study for the German Air Ministry. Submitted on June 7, 1939, the new proposal was accepted. On March 1, 1940, a contract for 3 airframes was awarded with the official designation ME-262. Simultaneously, and in the face of official apathy, Heinkel was rewarded with a similar contract. Even before the official contract had been signed, Heinkel had in fact cut metal on the first HE-280 prototype. The HE-280 was a quantum leap in aircraft design. Aside from the jet propulsion, the HE-280 was equipped with the world's first ejection seat and a tricycle landing gear. Prior to its first flight, a series of aerodynamic tests were conducted. Fitted with dummy engine nacelles, the prototype was towed into the air by an HE-111 and subjected to a number of gliding test runs. By March 30, 1941, the HE-280 V1 was ready for its first flight. With just enough fuel for takeoff, the HE-280 lifted into the air. After a single low-altitude, low-speed circuit, the HE-280 made a safe landing. It was the world's first jet fighter, but the world didn't take notice.
The Heinkel 280 was a state-of-the-art machine which no one really appreciated.
Just as the Germans were developing their jet technology, the Allies had their own secret jet programs as well. In England, Frank Whittle, like Ernst Heinkel, was battling against the same government indifference. The new jets were not a high priority. Frank's persistence, however, finally paid off. On February 3, 1940, the British Air Ministry issued Britain's first jet aircraft contract. Gloucester's aircraft was selected to meet specification E-2839. Design of this new aircraft was a collaboration between Frank Whittle and Gloucester Aircraft. The new E-2839 was a low-winged monoplane with the engine mounted behind the cockpit and equipped with a tricycle undercarriage, just like the HE-280. Air for the engine was drawn in from the nose and passed through ducts on each side of the cockpit. Like the Heinkel HE-178, the Gloucester E-2839 was one of the world's first technology demonstrator aircraft. Its sole purpose was to flight test Whittle's W1 centrifugal jet engine, which developed a modest 860 pounds of thrust. A remarkable aircraft by any standard, 2 examples were built. On May 15, 1941, the first E-2839 took off from Cranwell Airfield at 7:45 p.m. The flight lasted just 17 minutes. The promise of Whittle's engine pushed the Air Ministry towards an operational jet fighter. Even before the first E-2839 took shape, specification F940 for a new jet fighter was finalized in December 1940. Because the new jet engine didn't have the required thrust, the new fighter would have to be a twin-engine design. The F940 was not a radical or advanced aerodynamic design. Following accepted aircraft practices, it was fairly conventional. On February 7, 1941, Gloucester's received an order for 12 Gloucester Widow airplanes to the F940 specification. These would become the first Gloucester Meteors. Back in Germany, parallel work on the Me-262 was not proceeding smoothly. When the contract for the prototype had been issued, it was obvious to Messerschmitt that BMW had been unduly optimistic. The new BMW 003 axial flow engine was still unreliable, without sufficient power. It also had a substantially larger diameter. In order to accommodate the new, larger engine, Messerschmitt had to completely redesign his original airframe. The new aircraft would be larger, with the engines housed in underwing nacelles, just like the HE-280. While BMW struggled with their jet engine, the Junkers Aircraft Company was working on their own turbojet, the Jumo 004. This would provide a backup in case the BMW 003 failed. On November 1940, the Jumo 004 was bench tested for the first time. Major problems were revealed, and just as the HE-280 V1 made its first flight, Messerschmitt's first Me-262 V1 was fitted with a nose-mounted Junkers Jumo piston engine. It was not the start Willy Messerschmitt was hoping for. On April 5, 1941, the HE-280 was officially unveiled. To impress his guests, Heinkel arranged for a demonstration between a Focke-Wulf FW-190A and the HE-280. During the mock combat, the HE-280 completed 4 tight circles before the FW-190 completed 3. Finally, Ernst Udet showed some enthusiasm. Top speed was 485 miles per hour, 77 more than the FW-190. Impressed, the German Air Ministry sanctioned the manufacture of 13 HE-280A pre-production aircraft. Unfortunately for Heinkel, mass production of the HE-280 was still out of reach. Heinkel now found himself up against personal rivalries, duplication, and incompetent leadership. To understand this state of affairs, we have to return to the beginning of the new Luftwaffe. After Hitler took power, he appointed Hermann Göring as leader of the new Luftwaffe. A World War I ace and squadron commander, Göring soon gave a number of his ex-squadron mates titles in the newly formed Luftwaffe. Ernst Udet was one of the first. Many had no experience in aircraft production, or had any business background. By 1941, German aircraft manufacturing was in a crisis. Under the command of Ernst Udet, aircraft production had stalled. For the first year and a half of war, Germany was only producing 800 aircraft a month. It wasn't until after the Battle of Britain and the setbacks in Russia did the German High Command take action. Unfortunately for Udet, he was unable to effect any real change. In November 1941, he committed suicide. Udet's successor was Erhard Milch. Milch was an able, ruthless administrator, but he lacked the military expertise necessary for the job. Although he had good understanding of aircraft production, he was unimaginative and a conservative when it came to research and development. July 18, 1942. The first Me-262 is ready for its first flight. Unlike the HE-280, the Me-262 is a tail dragger. Because of the nose's high angle, most of the jet's thrust is wasted. After a problematic takeoff run, it takes to the air for a short 17-minute flight.
When the Messerschmitt 262 was first tested, it was a tail dragger. It had a tail wheel. And the only way you could get the thing up and level was for the pilot to put on the brakes, and so the aircraft would come up level, and then they could take off with it.
Across the Atlantic, America finally enters the jet age with the first flight of the Bell P-59A. The date is October 1st, 1942. By the summer of 1942, the HE-280 was still very much in the picture. In June, the HE-280 V2 prototype was re-engined with 2 Jumo 004A engines, each rated at 1,852 pounds of thrust. Now, for the first time, Both the HE-280 and the ME-262 are equipped with the same type of engine. Flight trials proved promising, with a top speed of 491 miles an hour being reached. A true comparison of the two fighters could now be made. Flight testing of the fourth ME-262 prototype showed that with the same power plants, it enjoyed a marked performance advantage over the HE-280. Compared to the straight-wing HE-280, the ME-262 looked faster. Its shark-like appearance and swept-back wings gave it a menacing presence. Even with this apparent advantage, the ME-262 still had a long way to go. For Heinkel and Messerschmitt, the road ahead was not a simple one. Both had suffered serious setbacks, their reputations now in question. In Messerschmitt's case, his new ME-210 twin-engine fighter was a complete failure. For Heinkel, the intractable problems associated with the disastrous HE-177 heavy bomber was a major distraction. By the summer of 1942, Germany was still victorious. After some unexpected setbacks in Russia, they were once again on the offensive. In North Africa, the First Battle of El Alamein began with Erwin Rommel leading the way. From a military perspective, Germany was at the height of its power, but it was now fighting on three fronts. Losses would be heavy. In September, the Battle of Stalingrad began with much promise. It was a bloody battle of attrition, and one in which Germans were losing. On November 1st, Allied troops break out of El Alamein. 7 days later, Operation Torch begins. Allied troops invade North Africa, with American and British troops landing in Morocco and Algeria. Rommel's fabled Africa Corps is now being squeezed on two sides. November 19th. Soviet forces launch Operation Uranus. Its aim, surround the city of Stalingrad and annihilate all German forces. The Soviet offensive is a spectacular success, and by the end of January 1943, the battle is all but over. The German Sixth Army surrenders. It was the first Nazi acknowledgement of failure. In May, the battle for Tunisia is over. German and Italian forces surrender, with 250,000 troops taken prisoner. These military losses represented a key turning point. Germany was now on the defensive. For the Luftwaffe, January 1st, 1943 represented a time of crisis. Its operational strength had sunk to some 4,000 aircraft. It had also failed to introduce new, more modern types, aircraft like the HE-280 and the ME-262. In fact, the Luftwaffe was drawing on its last accumulated reserves. Contingency plans were non-existent. Any new military setback would be catastrophic. The German High Command had resolutely declined the possibility of waging a defensive war. From Hitler on down, the mantra had always been attack. The losses in Stalingrad and North Africa put a severe strain on Luftwaffe resources. For the first time, serious cracks began to show. But it wasn't just the losses in North Africa and Stalingrad that hobbled the once mighty Luftwaffe. The pre-war belief that Germany's military conquests would be short led to short-term planning. New modern aircraft wouldn't be needed. It was a strategic miscalculation, and one that had a direct effect on the development of Heinkel's HE-280 and Messerschmitt's ME-262.
Heinkel was up against the German Air Ministry, even though he had Ernst Udet as his very good friend and confidant. The German Air Ministry, they wanted a flying machine propeller building like the Focke-Wulf 190, like the Messerschmitt Bf 109, that were designed for ground support, like in Poland and elsewhere.
For Heinkel, the battle for the HE-280 continued. As Germany's fortunes began to change, many still clung to the belief in a rapid victory, even in the second half of 1942. Erhard Milch was one of them. After Udet's suicide, he did manage to increase aircraft production, but at a cost. To avoid Hitler's wrath, Milch was unwilling to add any new types to the assembly lines. Doing so would cause monthly production numbers to fall. As a result, most of the pre-war designs remained in production right until the end of the war. Unfortunately for Heinkel and Messerschmitt, Milch's aversion to risk continued to have its effect in the one field where Germany could establish technical superiority: jet planes. In September 1942, both Erhard Milch and the German Air Ministry agreed. Any preparations for series production of the Me-262 would be premature, and in view of Heinkel's numerous commitments, production of the HE-280 was unrealistic as well. It was a curious point of view, but in early 1943, that all changed. In January 1943, Heinkel's HE-280 V6 prototype, powered by two Jumo 004 engines, took flight. For the first time, Heinkel pitched this version as a fighter bomber. In a complete about-face, the German Air Ministry changed its mind and began negotiations for the manufacture of 300 280s. It now seemed as if the 280 would finally see mass production and enter service before the Me-262. Ironically, the 262 V4 prototype, powered by the same Jumo 004 engines as Heinkel's new jet bomber, enjoyed a marked performance advantage over its rival. While the HE-280 was thought to be faster with a better rate of climb and ceiling, it only had 2/3 the range. In the end, the 262 was the superior fighter. In a letter dated March 27, 1943, Milch wrote to Heinkel, ending the 280 project. In Milch's letter, he claimed that the overall war situation today no longer allows us to run two designs side by side. For Heinkel, it was a bitter defeat. In a conference shortly after, Heinkel observed that Milch and his colleagues had a noticeable sense of unease about the jet, and the talk was always about jet bombers. For Willy Messerschmitt, victory over Heinkel would prove a Pyrrhic victory. Meanwhile in Britain, the Gloucester Meteor prototype DG-206 made its first flight. Like the Germans, British officialdom and industry were slow to deliver a reliable jet engine. Official confidence was shaken when the impellers on Whittle's W2B engine continually burst at high speed. This was eventually remedied with imported impellers from General Electric, who in 1941 built their own jet engines based on Whittle's design. Fortunately for the program, Rolls-Royce was called upon to take over development and production of the W2B engine. Back in Germany, development of the Me-262 continued. Compared to the British, the German program was disorganized, inefficient, and veiled in secrecy, even from those who should have known. Surprisingly, Adolf Galland, general of the Luftwaffe fighter arm, was kept in the dark. Not until May 22, 1943, did he fly the fourth 262 prototype. Galland was so impressed that he recommended production of the Bf-109 be halted and changed to the new jet fighter. Galland's enthusiasm swept away any remaining hesitancy and vacillation. 72 hours later, Erhard Milch ordered the 262 into series production. But many questions remained. Why did those involved in the program not see the value of the 262 sooner and act before Galland's endorsement? Why was it kept secret from Galland? And why didn't he fly the HE-280? One can only speculate as to what might have been if just 2 years earlier he had flown the 280. Finally, Messerschmitt had what he wanted, but there was one man who didn't agree. Adolf Hitler rejected out of hand any mass production of the Me-262. Said Hitler, "Nothing will be done with the new jet until I have decided on its merits." Unfortunately for Messerschmitt, the Führer was increasingly obsessed with revenge and retribution. Striking back at the enemy was far more important than providing his fighter arm with a fighter capable of defending the Reich. This would lead directly to Germany's third jet-powered aircraft, the V-1 flying bomb. Powered by a pulse jet engine, the V-1 was the world's first cruise missile and the first jet-powered aircraft to see combat in World War II. Shortly after D-Day, the V-1 bombardment of London began. To help counter the threat, the RAF deployed the first jet fighter, the Meteor Mark I. Compared to the HE-280 and the Me-262, the Meteor was slower. But more importantly, it was a combat-ready machine powered by centrifugal jet engines. Though the German axial flow engine offered more punch, Frank Whittle, the genius behind Britain's early jet engines, was sold on the reliability of centrifugal design.
Now, axial flow engines are much more complex than centrifugal, but much more efficient. Ideally, one should have headed for axial flow. But one has to put oneself back a bit in time and remember where we stood in the history of jet development, and that was not very far along the road. Whittle, quite rightly, when I talked to him, he knew all about axial flow, but I said to him, "Why have you gone this way, Frank, into centrifugal?" And he said, "Because in this present state of the art, I am looking for reliability and simplicity."
In November 1943, Hitler saw the Me-262 for the first time. Hitler scolded those in attendance, asking why, after years of demanding a fast bomber, was he presented with a fighter? Hitler wanted to know if the jet aircraft could carry bombs. Messerschmitt answered in the affirmative. For Hitler, the matter was settled. The Me-262 would be produced as a Blitz bomber. In fact, Messerschmitt disobeyed Hitler and continued to develop his jet solely as a fighter. 6 months later, when Hitler found out, he flew into an incandescent rage. On May 25, 1944, he ordered all 262s to be built as bombers. It was a major blow and added more technical problems to an already troubled program. One of the biggest and ongoing hurdles was the development of the Jumo 004 engine into a reliable power plant. The Jumo 004 was an axial flow compressor design. In theory, it offered more power over the higher drag centrifugal compressor engines used by the British. In practice, however, the Jumo engines were considerably inferior. The shortage of strategic materials like chrome and nickel led to the failure of many substandard turbine blades at high temperatures. The Jumo 004 also suffered from decreased thrust at high altitude, fuel flow problems, and flameouts if the throttle was opened or closed too quickly. The Jumo 004 was a technical and operational failure. Not only did the Jumo 004 have a very short lifespan, it was unreliable, prone to surges, stalls, and fires. This was the Me-262's Achilles heel, one Allied pilots would feast on.
The engines were very sensitive. They were slow to accelerate to throttle movement, and you had to handle them very carefully to avoid flaming them out. Secondly, the designers hadn't thought of how to slow down these incredibly fast airplanes, and no air brakes were fitted. And this made life very difficult, for example, for landing. You need some drag if you're going to land, and since there was very little drag associated with the 262, you had to do a long, slow approach to landing. And this was an Achilles heel, because the Ente USAF Mustangs realized this, and the 262s they picked off were usually in that phase of the operation.
By July 1944, the Luftwaffe's fighter arm was fighting a losing battle. Unable to cope with the swarms of long-range American P-47s and P-51 Mustangs, it was quickly being destroyed. While the Me-262 was in production, the numbers in operational service were meager at best, and would remain so until the end of the war. The first American B-17 shot down didn't occur until August 15th. For the Germans, the situation was desperate. Shut out since the rejection of the HE-280, Ernst Heinkel was finally brought back into the jet fold. Concerned with the slow production of the Me-262, the German High Command wanted a so-called rush job, a single-engine jet fighter that required little strategic materials to build. For Heinkel, it was a question of pride. Eager to prove himself once more, he accepted the challenge. Heinkel quickly realized that in order for the jet to work, the engine had to be mounted just above the fuselage, similar to the V-1. 12 days after the specification had been issued, the HE-162 mock-up was ready. On September 23, 1944, Heinkel's HE-162 was selected for mass production. Captain Eric Brown recalls demonstrating the HE-162 to Heinkel in a post-war test flight.
He was like a schoolboy jumping up and down with delight and asked very piercing questions about the handling of the aircraft. He had heard about the disaster we'd had with it. I found him with a very acute mind and struck me as a highly intelligent person.
By late 1944, the German High Command was fueled by fear, fantasy, and pathological denial. Galland said that the HE-162 was unrealistic. To mass-produce such a crude and untried aircraft and expect it to be flown by inexperienced Hitler youth was beyond reality. Even at this late stage of the war, Heinkel was working on at least 26 different versions. Using slave labor, 100 aircraft were produced in February of 1945. On February 6th, the first group converted to the new type. In the final weeks of the war, the so-called People's Fighter saw little action. Combat claims were made but never confirmed. Only one HE-162 was ever shot down by an Allied fighter. On May 5th, Germany surrendered. It was a crushing defeat. The new jet and rocket fighters introduced late in the war had no impact on the outcome. Many have argued that if the HE-280 had been produced sooner, history would have been different. Perhaps, but in the final analysis, the 280 wouldn't have made a dramatic difference. For Ernst Heinkel, there was a deep bitterness. His early groundbreaking developments were essentially ignored. As to who actually killed the world's first jet fighter, the answer is many. The HE-280 was quite simply a victim of mismanagement and industrial chaos. After 1936, Nazi management of the aviation industry was not centralized. Udet's technical office, Göring, the general staff, Milch, and all the aircraft designers jockeyed with one another for control of the aviation program. Instead of a uniform, consistent policy towards aircraft production, confusion and chaos reigned.
Göring must hugely accept blame for a lot of the failings of the Luftwaffe, particularly the delay and the mismanaging getting aircraft into production. And to a large extent, Udet was one of his causes of his problem. Udet was an extroverted, magnificent exhibition pilot in civil life, and he had been in Göring's squadron in World War I. Ernst Udet had no interest in politics, and Göring approached him as an old squadron mate and said, you know, the Nazi Party needs you and your experience. Come in and be the head of our technical department. Udet was talked into this and was completely out of his depth.
Firms like Heinkel and Messerschmitt tried to build everything from trainers to strategic bombers. Every effort made by the Air Ministry to move them towards any specialization was effectively countered. Clear-cut technical objectives were never issued. Programs were allowed to continue regardless of the enormous waste in time, skill, and materials. Overall, the Nazi management of the aircraft industry was uncoordinated, inefficient, plagued by ignorance and incompetence. Even if the HE-280 had become operational in 1942, its overall effectiveness would have been limited. It all came down to the Jumo 004 power plant. Unreliable with a critically short lifespan, it was not ready for combat operations. Serviceability rates would have been low, as was the case with the Me-262. Finding good pilots would have been another issue. The number of newly trained pilots could barely keep pace with attrition. Fuel shortages also began to take hold. By 1943, the Luftwaffe was a dying force with no chance of recovery. As the world's first jet fighter, Heinkel's HE-280 was a marvel of technology and inspiration. Unfortunately for Heinkel, those in power saw little use for his twin-jet fighter. Hitler's reluctance to produce jets almost certainly doomed what little hope Germany had of ever producing an effective jet fighter force. As the Allies sifted through the spoils of their victory, the incredible technology left behind, they counted themselves lucky that Germany had recognized the potential of jet power too late.
The jets were left absolutely untouched. Now, I was puzzled about this, frankly. What had motivated this? It certainly wasn't because it was overrun too quickly for them to have got rid of these jet aircraft. I think, deep down, it was a sense of pride of what they had achieved in the technical field, and they wanted us to see it.
In aviation terms, Konstantin Kalinin's K-7 was a classic exercise of early 1930s giantism, a massive aircraft for the time. And indeed, for years to come, it was destined to break much new ground and many hearts during its relatively short career. Despite the K-7's massive 175-foot wingspan, which was almost twice the aircraft's length, it was not particularly hard to fly, or even to handle. This was due to the fact that it employed a servo tab system on the control surfaces. These allowed the moving surfaces to be literally flown into position with very little effort from the pilot.
We were very interested in the type of controls because they were servo tab controls. At least half of them were servo tab and half were normal controls. They worked together. And it offers a lot of advantages in lightening up the controls, and they are very much less liable to enemy fire. They're not as vulnerable. If you strike the controls, you don't really put them out of action. You've got to put the small tab out of action, and that's a very different cup of tea.
For all that, the K-7, even with its 7 engines, was not the largest winged aircraft ever built. That distinction was still to be held by the German Dornier DoX flying boat, which was first flown in 1929. This behemoth aircraft was actually powered by no less than 12 engines and carried passengers who enjoyed unparalleled luxury. 3 DoXs were built and flew with relatively few mishaps, although they were never really practical or economically viable. However, also in 1929, another German manufacturer, Junkers, offered its G-38. 2 were built, and like the K-7 that followed, they were giant land planes, but not as large as the DoX. The G-38s were nevertheless big, and they also shared something else with K-7. Both aircraft were more or less flying wings, with a limited fuselage, purely to support the tailplane for added stability. With both the K-7 and the G-38, nearly all the aircraft's vital components were placed in their massive wings. The K-7 wing was particularly interesting, as Kalinin chose an elliptical shape, similar to that later employed on the British Spitfire, the American Thunderbolt, and some German Heinkel designs. Elliptical wings, although more difficult to make, have some aerodynamic advantages. The K-7 would have had the largest elliptical wings ever made. Kalinin's vision for the K-7 was that there should be 3 different versions. First, the heavy bomber. This concept would rely upon tremendous defensive fire. The 2 narrow booms that supported the tail would each house gunners, who would be able to reach their positions with the aid of their own powered trolleys connected to the main wing. There were also many other gun positions. The K-7 bristled with machine guns and cannons. There were even gun positions in each of the enormous pontoons that also housed the undercarriage. Kalinin also foresaw the K-7 as a giant military transport, which could carry large numbers of troops and other heavy loads that might even include light tanks, a capability that Soviet military planners had long been interested in. Finally, the K-7 was also seen as a luxury airliner, a passenger plane to challenge even the opulence of the DoX, and the exact opposite of what the proletariat revolution was supposed to have been all about. However, if Kalinин's ambition could see no limits to what might be done, a small group of Soviet planners were starting to rethink what had been done. 1933, the year that K-7 first flew, was also the year that the Nazi Party came to power in Germany. Now there were two large dictatorships, fascism and communism, both looking to influence Europe with their own dogma for a new world order. And both were highly militaristic. However, there were differences in the needs and thinking of the two powers. Germany would ultimately turn to using larger numbers of two-engine bombers, and in contrast, the Soviets, having to contemplate much greater distances, could see the need for a larger four-engined aircraft, although nothing like the size or cost of Kalinin's K-7. Soviet planners started to look more closely at a simpler design that they already had. The TB-3 from the Tupolev Bureau was much smaller than the K-7, with an all-up weight of about half of Kalinin's design. True, it had none of the sophistication of the K-7, however it was a proven concept, affordable and, most important, adaptable. Later versions even succeeded in towing a light tank fitted as a glider, the only time in history such a task was ever achieved. The TB-3 became a workhorse of the Soviet Army, and went on to provide years of valuable work long after its expected service life. About the time that the K-7 made its first flight, the United States Army was itself putting together specifications for another very heavy bomber under what would be known as Project A. The Boeing company was to be the successful contender with its Model 294, not quite as big as K-7, but still a very large aircraft indeed. Entering production, the 294 was given a service prefix XB-15. Only one example was ordered because the XB-15 was seen purely as a flying laboratory to test the pros and cons of giant aircraft. From concept to first flight, the project actually took over 4 years to complete. Such was the difficulty developing extra-large aircraft. A year after issuing specifications for the XB-15, the Army Air Corps released another requirement for a multi-engine bomber. Boeing, amongst other companies, were again given a contract to build prototypes. Boeing's XB-17 was flying within 1 year. By the end of 1945, over 12,700 fortresses had been built, and the Second World War come and gone. By contrast, only the one XB-15 was ever completed. However, it served its purpose. Both the US and the Soviets had adequately demonstrated that a large four-engine bomber could be a practical proposition, but not if it was too sophisticated or too complicated. The B-17 and TB-3 were basic and reliable. What happened to K-7? In November of 1933, during its 11th test flight, it crashed, the result of structural failure. 15 people died in the accident. Although the project did continue for a while, with 2 other prototypes commissioned, they were never finished. With the TB-3, and later the PE-8, Soviet planners established the need for large four-engine bombers, but not giants. Konstantin Kalinin went on to develop other ambitious aviation projects, including a pure flying wing and an advanced rocket plane. Sadly, Kalinin was arrested in 1938 and suffered the same fate as so many forward thinkers in Stalin's pre-war purge.
Dark and menacing, Northrop's P-61 Black Widow was a night stalker of the worst kind. Large, powerful and fast, the P-61 was the first American combat aircraft to be designed from the ground up as a night fighter. As large as a medium bomber, the P-61 was optimized for nocturnal air-to-air combat. Considered to be one of the ugliest fighters to see service, the Black Widow was in fact a killer. Beneath its slick black coat, the P-61 proved extremely efficient, invisibly approaching German and Japanese aircraft and blasting them from the sky. The birth of the P-61 can be traced back to 1940. During the unrelenting Blitz, German bombers roamed at will over Britain. Britain's night fighter force proved ineffective, but during the Blitz, a small number of fighters were equipped with the new and top-secret airborne interception radar. Desperate for an effective night fighter, the British showed the Americans their new radar in the hopes they could build a new fighter to carry it. British requirements were tough. The new fighter had to be fast, heavily armed, with a loiter time of 8 hours over the target area. Northrop rose to the challenge. Initial design work would begin in 1940, but it wasn't until late 1944 that the Black Widow entered service. Plagued by constant design changes, the P-61 prototype did not take to the air until May 1942. By June 1944, the P-61 was finally ready for combat. On July 6, the P-61 recorded its first victory with the destruction of a Japanese Betty bomber. In Europe, P-61s would gain glory by running up an impressive score against Germany's nasty V-1 flying bomb. 9 V-1 kills would be credited to P-61 crews. By the time the P-61s entered combat, targets were scarce in both Europe and the Pacific. In Europe, however, Black Widow intruder missions proved extremely effective. Night after night, P-61s would fly deep into Germany, destroying anything that moved. Large numbers of locomotives, supply convoys, and the odd bridge were destroyed. P-61 crews were also credited with a number of Luftwaffe fighters, both in the air and on the ground. In the end, only 2 squadrons would serve in Europe. The 422nd would be credited with 43 enemy aircraft destroyed, with the 425th chipping in another 10. The P-61, for all its promise and performance, was finally phased out by the United States Army Air Force service in 1950 and replaced by the F-82 Twin Mustang. But the P-61 would fly again, not with guns, but with eyes of a spider. Responding to the Air Force's need for a long-range photo-reconnaissance aircraft, Howard Hughes designed and built the XF-11. Unfortunately, on July 7, 1946, the XF-11 flown by Hughes crashed into a Los Angeles neighborhood. Continuing problems with the XF-11 caused the United States Air Force to cancel the project and turn to Northrop. The result was an order for 320 F-15 reporters. The F-15 was created using the XP-61E, the last fighter variant of the famed Black Widow. After just 6 months of flying time, the XP-61 was returned to Northrop for extensive modification. With guns removed, a new nose was fitted, equipped with a number of aerial cameras. Designated as the XF-15, this new aircraft flew for the first time on July 3, 1945. Using existing P-61 wings, engines and tail sections, the new F-15 Reporter had a more streamlined fuselage that housed a crew of 2 under a continuous bubble canopy. The revised center section had the pilot and camera operator sitting in tandem. The rear seat was equipped with rudimentary flying controls, which made it possible for the camera operator to aid the pilot on long missions. The aircraft's 6 cameras were placed in the elongated nose, replacing the 4 20mm cannon. Powered by 2 turbo-supercharged R2800 73 engines, the F-15 had a sparkling top speed of 440 miles per hour at 33,000 feet. In terms of performance, the F-15 possessed similar flight characteristics to the troublesome XF-11. This in spite of being powered by less powerful engines. The F-15 was accepted in September 1946. But by 1947, the United States Army Air Force cancelled the contract, leaving just 36 examples being accepted into service. During its operational lifetime, the F-15 Reporter did what it was supposed to do. Responsible for most of the aerial maps of North Korea, its contribution proved extremely valuable during the coming Korean War. The combat career of the P-61 Black Widow was an extremely short one. Measured in just months, it was the shortest of all the American fighters to appear in World War II. As America's first purpose-built night fighter, the Widow proved extremely effective. Unfortunately, its late arrival meant a combat record of unimpressive numbers. In fact, of the 35,000 fighter pilots trained by the United States, just 485 were trained as night fighters. While the F-15 Reporter would have a longer career, it was not a distinguished one. With just 36 built, the F-15 would suffer from poor serviceability rates due to a lack of spare parts.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.